Hello everyone, my name is Ananya Apsita. I'm a first year PhD student in the School of Mechanical Engineering at Purdue University. Today, I will be presenting the work that I have done with my colleagues on our system VR from X. In the recent decades, there is an increasing trend in the usage of virtual reality applications in education, entertainment, and industry. Many of them utilize real-world tools, environments, and interactions as basis for creation. However, creating such applications is tedious, fragmented, and involves expertise in authoring VR using programming softwares such as Unity, Unreal Engine, and 3D modeling software such as SolidWorks and AutoCAD. This hinders VR adoption by decoupling the subject matter experts from the actual process of authoring while increasing cost and time. VR from X is an in-situ DIY platform for content creation in VR that supports the authoring of interactive virtual scenes from real-world scans. Let's invite John, who is a welding expert and decides to transform his welding station into a virtual welding workshop. He scans his welding station using a 3D scanner. This scan can be stored as point cloud data and accessed across multiple platforms. John interacts with the raw point cloud and replaces the point cloud objects with corresponding virtual models through embodied interactions in VR. He adds the functions to the virtual objects and defines logical connections between them. Finally, the scene is ready for virtual welding. Now, I will explain the system features. VR from X allows users to interact with the scan point cloud using a brush tool. Using various features of the brush tool, users can select regions inside the point cloud or sketch in mid-air in a freeform manner. The point cloud selections or sketches are then fed into the backend system as input queries where neural networks are implemented to assist the users in retrieving and aligning their models of choice on the point cloud. After the retrieval process is complete, users can attach affordances to virtual objects to make them interactable. We define the intrinsic behaviors of virtual objects to be grouped into graphical animations in terms of motions or effects, panels used to display properties of virtual objects, control widgets to manipulate values or trigger events. Using an affordance recommender, users can attach one or more functions to the virtual objects. We ran an exploratory user study on a welding use case scenario with 18 participants to test the usability of VR from X. 15 users had prior hands-on experience with welding, out of which 8 were expert welders. The entire study was divided into 3 sessions. In the first session, users created the virtual welding scene by interacting with the point cloud of a scanned welding station using brush tool features. During the second session, users attached relevant behaviors to the virtual objects. In the third session, users performed virtual welding in the setup they created during the previous sessions. Our results show that the interaction processes in VR from X are easy to understand and use and do not demand any specific skill expertise from users. The system also provides an engaging and immersive experience inside VR through spatial and embodied interactions. In the second use case, we performed remote 3D printing, in which virtual models are retrieved by the brush tool and printed remotely by an IoT-enabled 3D printer. The third use case demonstrates the applicability of our system in human-robot collaboration. User specifies the path that the robot has to follow and authors the robot tasks in the virtual environment, and the robot performs the corresponding actions in the real world. To conclude, we have presented the system workflow design of VR from X that transforms physical reality into interactive virtual experiences inside a VR environment. Our study results confirm the usability of the system. We further implemented 2 more use cases to demonstrate potential applications. Thank you. If you have any questions, please reach out to me.